Have we covered this slide in the last session? Please look at your notes and tell me. We have done this one, that how if you change the conductivity, if conductivity is higher, it is for the stronger alkali. If conductivity is lower, it is for the weak alkali. So we have done this slide, right? So now let me just tell you about this thing, that why ammonia solution is different. Why ammonia solution is different? What is ammonia? Ammonia solution. When ammonia, you dissolve ammonia in water, okay, then it gives us ammonium ions and hydroxide ions. So you know that in sodium hydroxide, is it a strong base or weak base? Tell me. NaOH is strong base or weak base? You remember? NaOH is a strong base. So it dissociates completely 100% into Na plus and OH minus ion. Similarly for potassium hydroxide also, that is KOH, it is also a strong base. But ammonia gas is molecular. Okay, when it dissolves in water, much less than 100%. So it gives us ammonium ions. This is known as your ammonium ions plus hydroxide ions. Only some of the ammonia molecules form ions. There are fewer hydroxide ions present than the sodium hydroxide solution of the same concentration. If you take NaOH and if you take NH3, so this concentration of hydroxide in case of ammonia, it is smaller as compared to that in sodium hydroxide. So we say that sodium hydroxide solution, it is a better conductor than ammonia because it contains more ions. And what about pH? It has higher pH because it contains more hydroxide ions. If hydroxide concentration of hydroxide ions is more, so it is a strong base. So this is important, that the higher the concentration of hydroxide ions, the higher the pH. Is it clear? So you want to write it? Once done, please let me know. Good evening, Tino. Welcome to the session. How are you?
Good evening, ma'am. Sorry, ma'am, I'm late.
Okay, no problem. Take a screenshot of this slide. In this slide, I've explained that sodium hydroxide, it is a better conductor than ammonia because it contains more hydroxide ions. The higher the concentration of hydroxide ions, the higher the pH.
Yes, ma'am.
Done?
Yes.
Okay. Now this is your homework question for today. Homework questions for today. Question number 1 is, what do all alkaline solutions have in common? So take a screenshot of this slide and write an equation to show what happens when ammonia gas dissolves in water. So this question, the answer of this question is just in the previous slide. When ammonia gas dissolves in water, you have ammonium ions and hydroxide ions. And question number 1, you easily can do, what do all alkaline solutions have in common? What do they have? Hydroxide ions they have in common. Okay. So write down these questions, homework questions. Okay, so these are your homework questions. I hope it is done. Next is your acid reactions. This is very important part actually. How do acid reacts with metal? So always remember that when acid reacts with metal, you have salt and hydrogen gas as the product. For example, learn it with the help of magnesium. Magnesium, when reacts with sulfuric acid, that is H2SO4, you have a salt of magnesium sulfate plus hydrogen gas is liberated out. So the metal drives the hydrogen out of the acid and takes its place. It displaces the hydrogen. Okay, so what do you have to remember from this slide is only this. You can write down this and the example only, that when acid react with metal, you have a salt and hydrogen gas. Acid plus metal gives you salt plus hydrogen. So remember it by using the example of magnesium plus sulfuric acid. Okay, note it down.
Sorry, ma'am, I was having some network problems.
Yeah, okay, no problem. You can take the screenshot of this slide. Otherwise, I will send you the hard copy of the soft copy of the notes also of acids and bases. You can see that also. Done writing the slide?
Yes.
Okay. Okay, next is with bases. What happens with bases? When when acid reacts with base, we have a salt and water. So this is important. With with what? With metal. Metal reacts with acid to form salt and hydrogen. But when base reacts with acid, it forms salt and water. So this reaction is an example of your neutralization reaction. This is an example of neutralization reaction, where acids and bases neutralizes each other. So this is an example of neutralization reaction. So bases are compounds that react with acid, okay, that give only a salt and water. If we talk about metal oxides and hydroxides, they are bases, and non-metal oxides are acidic. Alkalis are soluble bases. Water soluble bases are known as alkalis. Example you can remember, for hydrochloric acid reacts with sodium hydroxide, we have salt, sodium chloride and water. Okay, next is sulfuric acid. It is your acid, as you can see by its name. Copper oxide is what? Basic or acidic? Tell me. Copper oxide is?
Basic.
Yes, it is basic. So acid and base reacts to form salt and water. So another example is this. Okay, sulfuric acid plus copper oxide gives you copper sulfate plus water. So write down this reaction, neutralization reaction. Acid plus base gives you salt and water. Okay, now what happens with carbonates? What happens when acid reacts with carbonates? So we have three products. Always remember we have three products: salt, water, and carbon dioxide. Example, write down the example. This is your carbonate, calcium carbonate. When it reacts with acid, okay, we have salt of calcium chloride, water, and carbon dioxide. Always remember when acid reacts with carbonates, you get salt, water, and carbon dioxide. These reactions are very important. Write it down.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Done. Okay. So bases such as
Yes.
sodium, potassium, and calcium hydroxide, they are all bases because metallic hydroxides are basic. So they react with ammonium salts like ammonium chloride, and it gives us ammonia gas. So this reaction is also important. Calcium hydroxide, when it reacts with ammonium chloride, you get calcium chloride, water, and ammonia. So this reaction is used for making the ammonia in the laboratory. So always remember that Such bases like sodium, potassium, and calcium, their hydroxide react with ammonium salts to form ammonia gas, to produce ammonia gas. Write down this reaction. Okay, so next reaction I've told you what is neutralization reaction. So write down definition. It is a reaction with acid that gives water as well as salt. Acid plus base gives you salt plus water. This reaction is your neutralization reaction. Neutralization is a reaction of base with acid that gives water as well as salt.
Ma'am,
Yes.
what if I write it as neutralization is a reaction between an acid and a base, which gives a salt and water. Is it still correct?
Yes, that is also the same definition. Both are correct.
Okay.
Okay, now how to make use, now let us see what is the use of this neutralization reaction. Okay, why it is necessary to study. So see, most crops grow best when the pH of soil is close to 7. If the soil is too acidic, that means less than 7, crops will grow badly or not at all. So it could be a disaster for farmers. So to reduce its acidity, what do the farmers do? They add crushed limestone to the soil. Limestone is calcium carbonate. Calcium carbonate is CaCO3. Or lime. Lime is calcium oxide. You should know all the formulas. And slaked lime is calcium hydroxide, CaOH2. So these all are bases, right? So when the soil is too acidic, then the farmers add these bases to neutralize the salt. Okay, so neutralization reaction will take place, and now the soil is not too much acidic. So this is the use and application of neutralization reaction in the growing of crops. Okay, is it clear? We'll study more applications. First application is this. Write it down.
Yes.
Tarantino?
Yes.
Next application, see here that these things, they are acidic. When bee bites, okay, then this is acidic. To neutralize that sting, we rub some baking soda. Baking soda is a base. What is a baking soda? Baking soda is sodium hydrogen carbonate. Or calamine lotion, it is also a basic, that is your zinc carbonate. Okay, so this is the solution, that these things are acidic. We have to neutralize that acidic part. So what do? We just rub our skin with some baking soda, which is basic, so neutralization reaction takes place. Or we use calamine lotion. Calamine is zinc carbonate, which contains zinc carbonate, so a neutralization reaction takes place. It is also basic. So this is the second application of neutralization reaction. So these questions can come up in your exam. These are your conceptual questions. Write it down.
Ma'am,
Yes.
didn't you say a neutralization reaction has the product water and a salt? So if it's a carbonate, won't they be carbon dioxide as well? Like zinc carbonate.
Yes. Then
So does that still make it a neutralization reaction?
no, I am just saying that if your bee stings are acidic, so we have to neutralize it. So from zinc carbonate, what are the products we get? From metal carbonates, what are the products we get? See here in this reaction, this is metal carbonate. When it reacts with acid, then you have the products as calcium chloride. Calcium chloride is what? Is it a salt? Tell me. Calcium chloride is acid, base, or a salt?
Sorry, ma'am.
Calcium chloride is what? Is it acid, base, or a salt?
Calcium chloride is is a base.
No, calcium chloride is not a base. It is a salt. When
Oh,
you're
is it?
yes,
Oh, yes. It's
the
not a
salt.
base.
It is not base.
Yes, yes.
Okay. And so here what happens when you are saying that when you react zinc carbonate is what? Acid, base or salt?
Zinc carbonate. Mm,
You can tell me? Is it acid?
no,
Base?
no.
Yes, zinc carbonate is basic in nature. It is basic. That's why we are applying the calamine lotion which contains zinc carbonate onto onto the skin in which bee stings have bite. Okay, so zinc carbonate, metal carbonates are basic in nature. Although it doesn't dissolve in water, but it reacts with acid. Okay, and it is a neutralization reaction. Neutralization reaction will happen and it will give relief to the pain. So you have to remember that zinc carbonate is basic.
Yes, ma'am.
And that reaction that you are saying, zinc carbonate, it reacts with acid to form salt plus water plus carbon dioxide. Yes, it happens. Carbon dioxide will evaporate. Okay, so that doesn't make any sense. Your skin, it will get neutralized by that bee sting. That is the purpose. Okay.
Yes.
This is your homework questions. I hope you can do these homework questions. 4 questions are there. First, you write a word equation for the reaction of dilute sulfuric acid with zinc and sodium carbonate. I have already told you which reaction is not a neutralization reaction. Salts are ionic compounds. Name the salt that forms when calcium oxide reacts with hydrochloric acid and say which ion it contains. Zinc oxide is a base. Suggest a way to make zinc nitrate from it. Write a word equation for the reaction. So if you have any doubt in any question, please let me know in the next class. First of all, you have to practice all these questions at your home. Is it clear?
Yes.
So are you writing it or have you taken the screenshot of it?
I'm writing, ma'am. I'm done, ma'am.
Now next we are going to define acids and bases in terms of your proton donors and acceptors. So remember that acids are proton donors. They have extra protons, so they are proton donors. While bases, they are proton acceptors. So acids donate protons and bases accept the protons. So if I ask you define acid and base in terms of proton acceptors and proton donors, so you have to write only this definition. This definition works only that acid are proton donors and bases are proton acceptors.